In chapter 2, we'll be looking at derivative. So we learn differentiations. Okay, so we do differentiation, and I suppose most of you have done before. Okay, when we talk about derivative, it's like the given y is x power n. Then we say that dy dx is n x n minus 1. That's the first formula you learn how to do differentiation. To differentiate x power n, you bring down the power n and then decrease the power n by 1. And you can also use the notation fx is x power n, and then f prime x is n x n minus 1. So you are differentiating y with respect to x. So dy dx is the derivative of y with respect to x, or the derivative of fx with respect to x. And sometimes I'll write it in short with respect to is wrt. Yeah? So f prime x, or simply f prime without the bracket x, is called the derivative. And it's also known as the gradient function of fx or f. And you also use the notation dy dx or df dx, differentiating f with respect to x. And the process of finding f prime x of a function is called differentiation. So we are doing differentiation in this chapter. These are some results you have done before. Differentiating a constant gives you 0. Differentiating ln x is 1 over x. And ex is a very friendly function because to differentiate e power x, basically you do nothing. You just give them e power x. And you also have the trivial functions. Differentiating sine function is cosine function. Differentiate tangent is secant square, and so on. Then it happens that the three trivial functions starting with c, after differentiating, there's a minus sign. And in the introduction of this chapter, I want to ask this question, how to derive this result. All this result, I suppose you have seen before. And my question is how to derive this result. How to know that differentiate sine function, sine x is cosine x. How to know differentiate x power n is n x n minus 1. And the answer is using limit. Using limit. And let's see how to use limit to find the answer. If you do the next course, like MA 1312 or MA 1521, you'll be learning how to find derivative using the concept of limit. And the derivative f prime a is defined to be limit x tends to a fx minus fa over x minus a. And derivative can also be interpreted geometrically. So geometrically we call it the gradient function, the gradient of the tangent line. Derivative is the gradient of the tangent line. And for the gradient, right, in this course sometimes you use the word slope. So for this course, slope and gradient, they mean the same thing. And derivative can also be interpreted as instantaneous rate of change of the function. So I'll tell you these three things. Derivative, why you define derivative using the concept of limit by this fraction, limit x tends to a fx minus fa over x minus a. And why derivative you can take it as gradient of tangent line. And y derivative will give you instantaneous rate of change of the functions. Okay, let me show you what to do. Okay, we start with something simple. If you have a straight line, you know that the equation is y equal mx plus c. And c is the y-intercept. And n, the coefficient of xn, right, is the gradient of the line, or we call it the slope of the line. So for straight line, gradient is just the coefficient of x. If you want to find gradient or slope of a line, you take 2 points, like A is x1, y1, the B coordinate is x2, y2. And to find the gradient n of the line AB, you take y2, the y value minus the y value, y2 minus y1 over x2 minus x1. And you will get gradient of the line, straight line. And for a curve, because the gradient keeps changing, and we define the gradient at a point A. If you want to talk about gradient at A, you must first draw a tangent line. So we draw a tangent line at A, which is the blue line, and then after that, we say that the gradient at A is the gradient of the tangent line at A. And I will explain to you why you have this expression, why it's same as f prime A, which is limit x tends to A, fx minus fa over x minus A. So I'll be telling you why. Right? So the question is, why we define f prime A to be this limit of this fraction, limit x tends to A, fx minus fa over x minus A. To answer this, right, first we choose a point B. You choose a point B. A is a point with x value A, so y value will be fa. So you choose a point B on the curve, and the x value is x, y value is fx, and you try to find gradient of the line AB. Remember, if you look at the red line, it's a straight line. For a straight line, to find the gradient, it's just y2 minus y1 over x2 minus x1. So y2 is fx, y2 is fx, y1 is fa, so that's why it's fx minus fa here. Then x minus a, because at B the x value is x, at A the x value is a. So you see this fraction. So now you see why you have this fraction. To answer why you define f prime A to be limit x tends to A. Now I answer see why you consider x tends to A. If you look at the blue line and the red line, of course the gradient are the same. The gradient at A, right, is the gradient of the blue line, gradient of tangent at line at A. Of course, it's not same as the gradient of the line AB, which is a red line. There are two different lines. And you'll find that the point B, right, you can choose it differently. You can choose point B closer and closer to A. If you choose point B closer and closer to A, then you'll find that the red line will get more and more parallel to the tangent line at A. So the red line will become more and more parallel to the gradient of A. The gradient of the line AB will be getting nearer and nearer to gradient of the line A. And you look at choosing B closer and closer to A. To choose B close to A is same as you choose X nearer and nearer to A, right? So which means to choose B closer and closer to A is same as letting X approaches A. So by taking limit means you choose B as close as possible to A. It's same as you choose X as close as possible to A. Then you see gradient of the red line will be same as gradient of the tangent line at A. And gradient of AB is just this fraction. Gradient of AB is just this fraction. So that's why you define limit x tends to A, fx minus fa over x minus A to be the gradient at A. Okay. Next, I want to show you why gradient at A gives you instantaneous rate of change of the function. I want to show the last one. Remember just now at the beginning of the video, I mentioned this. I'm going to show you three things. Derivative. You define derivative using concept of limit. Okay, so I'll show you why you have this. And then derivative is the gradient of the tangent line. And with that, you know that we have 1 and 2 already. So next, I want to show you why derivative is same as instantaneous rate of change of the functions. And to do that, right? You look at gradient. You look at straight line. If I give you y equal to 2x plus 5, so the gradient is 2, right? So in this case, m is 2. So when m is 2, what can you say about the functions? You can put x as 1, y will be 7, right? It will be 2 plus y 7. You put x as 2, y will be 9, right? It will be 2 times 2, 4 plus y 9. You put x as 3, y will be 11. You put x as 4, y will be 13. So we see that actually it's like that. So you see that if you increase x by 1, y increase by 2. So it's like plus 2 here, plus 2 here, plus 2 here. Then if I give you y equal to minus 3x plus 1, so this time the gradient is minus 3. If you put x as 1, y will be minus 2. You put x as 2, y will be minus 5. Put x as 3, y will be minus 8. So this time you see that you decrease by 3. If you increase x by 1, y value decrease by 3. From minus 2 become minus 5 and minus 8. So if n is 3, you know that decreasing. So decrease by 3. Decreasing by 3. Right? Decreasing by 3. Decreasing by 3. If the gradient is 2, then you find that increase by 2. The rate increased by 2. When we talk about rate of change, we talk about what happens to the y value when your x changes. So that's the rate of change. So you'll find that the rate of change is 2. If you increase x by 1, 1 increase by 2. So gradient tells you rate of change. If the gradient is minus 3, if you increase x by 1, y decrease by 3. So gradient gives you rate of change. So similarly, when you talk about derivative f prime a, will give you the instantaneous rate of change of the function at the point a. For a curve, the instantaneous rate of change will be different. At different points of the curve, the instantaneous rate of change is different. For straight line, because it's constant gradient, so constant rate of change. So gradient also gives you rate of change according to the gradient of tangent line at the point A you're looking at. So gradient gives you rate of instantaneous rate of change.